Hello, everyone, and welcome to our monthly drought briefing for areas in extreme and exceptional drought in the Western US. This webinar series grew from a collaboration in the Southwest Drought Learning Network, and I would like to acknowledge the USDA Southwest Climate Hub and the Colorado Climate Center for their role in organizing this meeting today. This monthly webinar gives an update on Southwest drought conditions and resources. This is the fourth of what we anticipate will be several monthly webinars in the region. We plan to do these on the third Friday of every month for as long as the Western region is experiencing these extreme drought conditions. However, the next one's going to be an exception. Next month, we're going to be doing the webinar on the second Friday, which is Friday the 12th at 11 a.m. Mountain Time, and that's currently planned to focus on Snowpack. My name is Joel Lisenby. I am the Regional Drought Information Coordinator at the Intermountain West and Southern Plains regions at the National Integrated Drought Information System, or NIDIS. Just a little bit about NIDIS, if you're unfamiliar with us. It's our mission to help the country move from a reactive to a more proactive approach to managing drought risks and impacts. And you can learn more about us at drought.gov, which we're going to be learning more about later in this meeting. To begin, I would like to acknowledge that the land each of us is on today is the ancestral land of tribal and indigenous cultures, and I pay my respect to their elders and chiefs, both past and present, and I welcome all tribal and indigenous peoples who are joining this webinar today. The format for today's webinar will be a presentation by our two invited experts, followed by a time for questions and discussions at the end. We plan to wrap up at about 11:30 Mountain Time. With a group this large, we found that the Q&A session goes smoother if you will please type your questions into the question box, which in the GoToWebinar software, that's a little different than the chat box. You'll see one that says chat and the other that says questions. Go ahead and type into the question box. And at the end of the meeting, we will direct your questions to the panelists and they'll answer it. The questions will be moderated by Maud Dynan. Maud is a program specialist at the USDA Southwest Climate Hub. She primarily works with drought adaptation for agriculture committees, and she helps develop events and resources that make drought knowledge accessible and actionable. So I'd like to welcome Maud, and at the end, we'll be hearing from her as she moderates the questions. We're going to be making these webinars accessible after the webinar is over. Everyone is muted, and this webinar is being recorded. The recordings will be made available at the Southwest Climate Hub YouTube channel, which I'm showing here. Also, we'll be putting it on drought.gov, and you can also find it at www.drought.gov/webinars, and you can find an overview of the webinar there. I'd like to welcome and introduce today's speakers. Our first speaker will be Peter Goebel. Peter is a service climatologist and drought specialist at the Colorado Climate Center based at Colorado State University in Fort Collins, Colorado. Peter will be talking about current drought conditions and forecasts across the West, especially the regions impacted by drought. And immediately following Peter, we'll be hearing from Kelsey Satolino. Kelsey is the digital communications coordinator for NIDIS, and she's going to give a brief demonstration of the new US Drought Portal, which is drought.gov. So with that, I'm going to pass over to Peter. Peter, I'm going to give you permissions to share your screen, and you can go ahead and start.
Sounds good. Let's see here.
It always seems to take a little longer to change this than we anticipate.
There it is. So show my screen, and now I should be up.
Yep, we can see that and hear you fine, so go ahead.
Okay, thank you, Joel, for inviting me, and thanks so much, everyone, for being here. Like Joel said, I will be doing just a quick review of some of the current drought conditions across the greater Southwest area of the US. I'm going to kind of have this divided into three sections of where we are now, how we got there, and what the next few months are looking like. So the US drought monitors, many of you have probably been staring at this map a lot in recent or many weeks. This is a look at where we are. It's the US Drought Monitor's appraisal of drought conditions across the Western US, with that D4 or exceptional drought covering significant portions of especially Utah, Arizona, and New Mexico, as well as parts of California, Nevada, and Colorado. And then we see some pretty widespread D3 or extreme drought. Between D3 and D4, we're looking at conditions that are reflective of largely the bottom 5 percentile of conditions across the historical distribution for this area. Now, it's important to note, though, that the US Drought Monitor is standardized based on season. So, for instance, you wouldn't expect a D4 in February to match a D4 in July in terms of impacts. And I think that's the other important portion of covering kind of where we are today, is that it is winter. And that is important when we talk about drought conditions in the region, because our impacts of drought are so heavily seasonal across much of the Southwest. The winter is generally when we build our water supplies back up through snowpack in the mountains, but then the summer, when we're using that water, when it's ranching season, when it's growing season for general crops, that's when we tend to see the drought impacts hit if the water isn't there. Here's just a map on the right-hand side of departure from normal temperature over the last 7 days. So for a lot of the Southwest, it hasn't been that anomalously cold, but for much of the center of the country, boy, has it been winter over the last week or so, with snow making it all the way down into central and southern Texas. And when we have these cold conditions, it sort of has this impact of arresting drought impacts for the time being, or suspending them. But when you have really cold air, cold air also can't hold as much moisture, so it's harder to, in some senses, recover from drought when it's really cold out as well. Now, in terms of where we've come from, here is a quick map of historical rankings of precipitation statewide out of a range of 126 years, so going all the way back to 1895. This is based on weather station data from long-term weather stations. And if we look at the Southwest region for the calendar year of 2020, we see that it was recorded by National Centers for Environmental Information Climate at a glance as being record dry for both Nevada and Utah, and the second driest year on record for Arizona, New Mexico, Colorado, and then even in California and Wyoming, we saw top 5 driest year on record. And when conditions are this dry across the Southwest region for a calendar year, oftentimes it takes several years to dig back out of drought. We can see a really good snow year where we dig out more quickly, but when we have more average type years, it takes quite a while to muscle out of these types of conditions. And then if we look at the same map, but for temperature, here we are looking at how things rank versus the historical distribution in terms of average temperature, and we see that it was the hottest year on record going back to 1895 for California and Arizona, and then a top 5 hot year for Nevada, Utah, Colorado, and New Mexico, and it's up there for Wyoming and Oregon. So definitely a warm year, and of course our temperature conditions are not in a steady state. Our climate is warming, so that is a part of this. And then the other big thing is when you have dry conditions, that often comes hand in hand with warm conditions in our region, as it's generally a trade-off between, are we spending more time baking under high pressure ridges, or are we getting more storms either dropping in from the northwest or coming out of the west and bringing some good Pacific moisture? So when we have those storms, we tend to see cooler. So definitely fitting well within the hot and dry mode over the last calendar year. And then kind of the most extreme portion of that was the portion of the year from June through September. Again, this is the time of year where we see drought impacts hit the hardest. Also, it was critically hot and dry during this time frame. We're looking at the Standardized Precipitation Evapotranspiration Index, or SPEI, which factors in both the influence of temperature and precipitation on the surface water conditions. And we're seeing SPEIs well below the -2 mark, even below the -2.5 mark in places like central Arizona and portions of Nevada and Utah. That's reflective of D4 conditions. In fact, much of the area covered in red we can essentially think of as D4 conditions, and this led to one of really an unprecedented fire season across much of the Southwest U.S. Certainly California and Colorado saw many, many acres burned in the summer and fall of 2020. If we look forward to recent months, here is a map of the snowpack accumulation to date. So we're about 2/3 of the way through the snowpack accumulation season. And actually, if you asked me to look at these numbers in a vacuum, they're not too bad. We're seeing conditions largely in the 80 to 100% of normal range for this time of year. I am concerned about regions like northern Utah, where we're seeing lower than 80% of normal. That takes a few good storms to dig out of, but if we're looking at, say, the western basins of Colorado, which are really important to overall runoff in the upper Colorado River Basin, these deficits are in the range of 1.5 to 2 inches of snow water equivalent. So really one good storm behind. And again, that wouldn't be the worst thing in the world if we were just looking at this in the vacuum. But if we look at our groundwater conditions, we see that we went into this season with really low antecedent soil moisture, low base flows in terms of stream flow, and a really shallow water table. So it's going to take some extra water at some point to start to make that up. As is, we expect our runoff is likely to be less efficient than normal, as our soils are quite thirsty right now, and a lot of our snowpack is going to filter into the soils before ending up in lakes, streams, and reservoirs. Our reservoirs themselves are also on the lower end of normal, and of course, if you look at our reservoir giants in the area, like Lake Mead and Lake Powell, this problem certainly precedes the current drought. But for instance, Lake Powell is at only 54% of its average storage, based on that 1981 to 2010 normal. We don't see a dot for Lake Mead here, but it's also between 50 and 60% of normal for this time of year in terms of storage. And then if we look at smaller reservoirs throughout much of the upper Colorado River Basin and the greater Southwest area, we're storing less water than we have historically. So we have thirsty soils and thirsty reservoirs. So a little bit shy of average snowpack just isn't going to get the job done. If we take a look forward to the next few months, this is the Climate Prediction Center forecast for March, April, May. It's a probabilistic forecast, so we're showing whether there's increased probabilities of below normal precipitation or increased probabilities of above normal precipitation. You see that the probabilities are skewed towards higher chance of below normal over the March, April, May timeframe. I should also mention, there's about 10 days left in February. February, the remainder of the month is looking like it may be a little bit on the drier side, but will largely, conditions that we see right now will largely persist in terms of the snowpack percent of normals. I expect those not to change much over the next 10 days. This forecast is driven by both statistical and dynamical models. So we are in a La Nina year, and La Nina springs, there isn't much historical precedent for wet extremes, if any, across the Southwest US. As you get further north into northern Colorado and Utah, and even into Wyoming, there's a bit more historical precedent for having wet years or wet springs during La Nina conditions. Just the further southwest you go, the rougher it gets. Also, in terms of overall climatology, the March, April, May, or especially as we get into April, May, tends to get into the dry season for the southern portion of our Southwest region. But if you look at the northern portion, it's more the wet season. So just in terms of climatological precipitation distribution, there's more chance for us to make things up in the northern fringes of where we're seeing this current drought. So I think that's about all I've got for you today, but just a couple takeaway points that I wanted to rehash before leaving you here. Cold weather puts drought impacts on hiatus, but we're still dealing with considerable deficits from 2020, as 2020 definitely fell into the hot and dry end of the historical distribution. Region-wide snowpack is below historical averages. Like I said, if you're looking at snowpack in a vacuum, it's not terrible for most places, but when you consider the antecedent conditions going into this winter season, it's really going to take more to bust this drought. And then spring conditions could make a significant impact either way at this point. Certainly a wet spring could do a lot to dig us out of drought, but if you look at forecasts from places like the Climate Prediction Center, they tend to favor drier conditions to persist. So it definitely makes sense to be prepared for a low runoff year at this point. So with that, I will see if I can go ahead and pass back my screen to Joel, but thanks again so much for having me.
Yep, thanks for that, Peter. I'm just going to pass straight over to Kelsey.
Hi, everyone. Hopefully you all can see my screen. My name is Kelsey Satolino. I'm the Digital Communications Coordinator for the National Integrated Drought Information System, or NIDIS, and I want to take the next few minutes to show you the newly redesigned US Drought Portal, or drought.gov. We launched a redesign of the website in January, and as Joel mentioned earlier, we think this website will help with NIDIS's mission of taking a more proactive approach to managing drought conditions and impacts. The new Drought Portal features updated content and new interactive maps designed to provide actionable, shareable information and graphics describing current drought conditions, forecasts, impacts, and planning resources. So over the next few minutes, I want to show you a few of the key new features of the redesigned website and how it can be useful for looking at drought in the Southwest. And you'll notice a lot of the same maps from Peter's presentation are kind of integrated into this site. So the first new feature of drought.gov I want to highlight for you is the ability to view drought conditions at a much higher resolution. So either on our homepage or through the by location section of our menu, you can enter your city, zip code, or county and be immediately taken to a page that has up-to-date drought information down to the city or county level. The maps and graphs on these pages are interactive and they're updated automatically, giving you this very high resolution drought information. So this is the city page for Salt Lake City, Utah, as an example. These pages contain current conditions, key indicators of drought, drought blends, future conditions and outlooks, and historical conditions down to the county level, which I'm going to talk about more in just a moment. So I'll come back to that. The maps on these pages are interactive. You can zoom in or out, switch between different timescales, and click on a county to jump to a different county's drought information. I'll quickly show you an example of drought information at the county level that you can view on drought.gov. We've tried to make it really easy to view the information that you need at whatever geographic scale that you're working with. So the county level pages on drought.gov contain a lot of the same information as the city level pages, but with a few key additions. You'll notice throughout the website, we've got these blue boxes with quick statistics showing not only drought conditions at a high level, but how those conditions compare to past conditions. So Peter mentioned the National Centers for Environmental Information's Climate at a Glance rankings. And on that map, Utah had the most dry year in the last 126 years in 2020. So on this page, you can see that same information pulled in at the county level. This is updated for 2021. So 2021 so far is the 35th driest year to date for Salt Lake County specifically. In addition, these county level pages also contain maps showing the impacts of drought on different economic sectors, such as agriculture and water supply. This map, for example, contains US Geological Survey streamflow conditions. And in addition to interacting with the map in general, you can also click on a particular stream gauge to jump to the US Geological Survey's website with more information for that stream gauge. So it's just one example of how we've tried to make this information really interactive and accessible. We also have maps showing the impacts of drought on public health, including National Weather Service heat warnings, as well as the CDC's Social Vulnerability Index, which uses census variables to help local officials identify communities that may need support in preparing for or recovering from hazards like drought. So I'm going to jump up to show you just one more example of the pages in our by location section to show you a state level page. Now we have these pages for all of the US states, as well as some US territories. These pages contain current and previous US drought monitor conditions, historical conditions at the state level, upcoming events relevant to that state, including webinars like this one, related documents, and a curated list of web resources. Now these state level resources not only include links to key regional partners like the USDA climate hubs and regional climate centers, and National Weather Service weather forecast offices, but also state level drought planning resources, state drought task force and agencies, and other key resources at the state level. I just gave you kind of a brief whirlwind tour of our by location section, but we have a lot of other geographic scales available too. For example, you can view drought data maps and tools by drought early warning system region or DEWS region, as well as at the watershed, tribal, national, and international scales. The goal is to make it easy to view drought conditions for whatever geographical region that you're working with. The second key new feature of drought.gov that I want to highlight for you are the interactive data and maps and new ways of displaying that information that allow you to easily visualize and share drought information. You can view national data and maps by topic here, from snow drought to agriculture to water supply and more. I want to briefly show you our historical data and conditions page as an example. One of the biggest questions we get is, how does current drought conditions compare to historical conditions for my region? Our historical data and conditions page contains a fully interactive graph, map, and legend with updating statistics on drought conditions, comparing 3 different historical drought data sets side by side. So we have US Drought Monitor data going back to the year 2000, a 9-month standardized precipitation index, or SPEI, from the National Centers for Environmental Information going back to 1895. And also from NCEI, we have paleoclimate data from the Living Blended Drought product, which combines tree ring reconstructions with instrumental data to estimate the drought values each summer, going back to the year 0 for some regions of the US. You can easily zoom in to view a specific time period in more detail, move the cursor to select a specific time range, and then click on a state to load that state's historical information, and the graph, the statistics, and the map will all update automatically. You can even dive down to the county level to view drought information, which can be really useful for drought planning. Once you've found what you need, it's easy to learn more about the data or to download a screenshot of the map for easy sharing. And these download screenshot links are present throughout the website to make it really easy to share the data and maps from drought.gov. The final thing I want to show you is our brand new by sector section, which shows drought impacts on different sectors of the economy. These pages serve as a landing page for not only people who work within these economic sectors, but those who work closely with them. Each page contains a featured map or maps, as well as some key statistics. So for example, on our agriculture sector page, we are showing crop and livestock information from the USDA's National Agricultural Statistics Service, overlaid on top of the current US Drought Monitor, as well as some key statistics on crops and livestock in drought, as well as USDA drought disaster declarations. Each of these sector pages contains a brief overview of key issues related to drought and that sector, a more in-depth background on drought's impacts on that sector, and a curated list of resources for drought early warning for that sector to, again, like Joel said, help us take a more proactive approach to planning for and mitigating the impacts of drought. Overall, whether you want to explore drought information by topic, by economic sector, or by geographic scale down to the city or county level, we've designed the new drought.gov to help you easily find and share the information you need to help your community better prepare for and mitigate the impacts of drought. You can explore it for yourself at www.drought.gov, and you can email us at drought.portal@noaa.gov with any questions or feedback about the website. We would love to hear from you. Thank you, and with that, I will stop sharing my screen. If I can.
Thank you, Kelsey, and thank you, Peter. Those were great. We have a few questions coming in through the chat box or the question box, and that's just a reminder for anyone who has questions, send those through the question box and we'll try to get through them before the half hour. This first question is for Peter. What are the odds of a double dip La Nina?
That's largely uncertain at this point, but it's an important question because double dip La Nina years have not been kind to the Southwest in recent years. So 2012 was a double dip La Nina, as was 2018, I believe, and those were both poor snowpack years. Double dip La Ninas tend to favor wetter conditions in the northwest and northeast corners of the US, but drier elsewhere. The ensembles that I've seen for the coming months tend to show this La Nina fading out throughout the remainder of the spring and summer and kind of trending into the neutral territory. But then once you get into next winter, there's a lot of uncertainty as to whether we bounce straight into an El Nino or double dip. So wish I had a less wishy-washy answer there.
Thanks, Peter. We have a few folks asking about this, and this might be more of a Joel question, but they're enjoying the speedy input of information, but they're wondering if there might be another opportunity for a more in-depth overview of the topics covered, either as a website or another educational opportunity.
Sorry, I was muted. Well, I think that certainly is an option. Kelsey put together a YouTube video that you can watch. Kelsey, is that just on the NIDIS YouTube channel?
It is, and I'll link to it in the chat, and I'll also put a link to our drought.gov feedback email. So if you have questions about the new website or any features within it, or technical questions, or just general feedback, or want to learn more about it, we encourage you to reach out to that drought.portal@noaa.gov email. So I'll include both the link to the demo that I've made on our YouTube channel, as well as that email, and we can follow up with you for more information.
Sure, and I think that if there's a need for a large group to get a more in-depth dive for this, that's something that we could probably set up on a case-by-case basis. Is that right, Kelsey?
Yes, it is. And if you reach out to that Drought Portal email, that's something that we can talk about if we want to do that on a case-by-case basis.
Great, thanks.
Great, thanks, y'all. And we have one last question, which will be great to hand over to Joel to wrap up this webinar, but will links be provided to the graphics with the webinar recap? And maybe this is a great time to share what else can be shared in the updates and upcoming events. So I'll hand it over to you, Joel. Thank you.
Great, thanks for that, Maud. And so Peter showed quite a few links through his presentation. Peter, if you share that with me in an email, I can put that on the webinar recap on drought.gov. So that's where you'd be able to find that. I'd like to thank, first of all, our expert presenters, Peter Goebel from the Colorado Climate Center and Kelsey Satolino from NIDIS. Thank you for taking your time and sharing your expertise with us. And also thanks to Maud for directing the questions. And thank you to all of you for joining. Our next webinar, our quick drought briefing, this half-hour drought briefing, is scheduled for Friday, the 12th of March at 11 a.m. Mountain Time, and I hope to see you all then. Be looking out for an email with the registration link. That should be coming out in about a week or two. Thanks, everyone. Goodbye.